Can you see this? Yeah, 10:00. Good morning, students. How are you? I can see 4 students online now. I don't know, many more would be joining us soon. Please circulate this link. Just check if the link is working. Send me a feedback. Please note my number. Oh, great. Mantri, you are online. R. Mantri, great. Madhuram. Then who are the others? I can see now 7 people online. That looks good. So that means this link is working. Can you hear my voice properly? Can you hear my voice properly? I have muted now. I have tested all these audio videos. Just let me know feedback so that I can start. Eric, who is this? Epic Footballer, GM. Good morning. Who is Epic Footballer here? Then who is the other guys? There are 6 guys now. Okay. Let me wait for some more time so that others can come online. Just give me the feedback. You are able to hear my voice. Okay, good. Guru GK. Thanks, Guru. Thanks for your feedback. So now let me start the session, or should we wait? Pratik, good. Good morning. Good morning. How about your friends? Where are those? How is your vacation? Kind of. Post homestay. How are you people feeling? Just type it out. I can view that before I start my class. There will be some initial hiccups, so I just want to overcome those 5-10 minutes so that we can start the class lecture once the other your friends join our live stream. Please share this link. Lot of efforts I have taken to see that I should come online, discuss with you people, then share my thoughts, and then as well go ahead with my topics on unit number 2, limits, fits and tolerances, in which today I am planning to discuss about gauge design. I think you must have seen yesterday my lecture on yesterday. There were about 6 or 8 students. I expect the number to go up today. I have taken enough care, I have precautions, tested, deleted those videos since many permutations. It's a story, I should say, maybe some other time, not now. But finally all is well that ends well, if this is live streaming is reaching you people. I can only get back. Oh, so boring, sir. Why? Who is this? Epic? No, for me. Can you see me? Do I feel boring for you? No. It all depends. You should start working. For last 8 days I have been working on this platform. What is this? OBS platform, YouTube streaming. I found it to be very exciting, interesting. I don't have spare time for that matter. Otherwise, yes, at times it may tend to be boring, like the same YouTube channels or videos or WhatsApps and stuff like that. I can understand. We can hear you, sir. Yes, good. Pratik, okay. Then still, as I can see, 7 viewers. I want the more. I want higher numbers. I don't know why. What happened to your friends? What are they doing now currently? Any idea what they are doing? Not yours, sir. No. Not you, sir. Vacation. No, I got it. What I said is, I got your viewpoint that it is not about my lecture or anything, not boring. What I got is, you are getting bored at home, staying back. Yeah, at times I do understand, but I was referring to myself. I am not getting bored. I am very much occupied with learning. Anything that comes new, it excites me. All these times I was always having, for years, whenever I used to see what's the YouTube online tutorial classes, I used to see this corner window, IIT professor or some lecturer or somebody, they are giving you the topics, and then effortlessly they are moving from, normally they have a mounted camera on the top, so they move the slides. Okay, just a minute, I have one more camera. I just showcase that. Can you see this? Yeah, look at this. So effortlessly they are moving from one slide, then see on the background they have PPT. I doubt I was always doubting how these people are doing all these lectures. There are two ways of live streaming the lectures. Please know this. There are two ways. One is direct live streaming on YouTube, wherein the flexibility is very limited. Okay, you can see my video or the presenter's video on full screen. It is quite useful for theoretical subjects where it is only one-way delivery. You don't need a PowerPoint presentation. It is only the discussion of some even, but any given point of time, if you want to write something, you will get stuck in that. Otherwise, you will have to go in the layman's way, write something in this sheet and hold it before a camera. It looks thoroughly unprofessional. So I was wondering how this online classes are being conducted. What is the way to do this? Then for 7-8 days I worked on that, and this is now the final situation. I think you can see now while giving the lectures, I can start working on this. I will discuss all these things whenever I want. I can come back to the drawing sheet. Then if I want, I can go back to my PDF file. Yeah, can you see this? Then I can showcase. Can you see? Yeah, now look at this. So all this is possible. Correct. So can you see the PDF file now? Yeah, this is the way I always wanted. And like it should be in an open classroom where I discuss the material. I'll be showcasing through the projector. You can see the PowerPoint presentations on the screen, as well as I can use the board. Here my board is replaced by this drawing sheet or any sheet I can write here. I can showcase that. My PDF you can see here, and of course you can view me as well parallelly. Looks good. All set. I can see 15 students. Arey wow, that looks good. Who are the newcomers here? Epic, boring. No, not you. Wait 2 minutes. We'll call our friends. Oh, that looks great. Great. Epic. I will wait for your feedback. I will wait for some more time. Wait for another 5 minutes. Not a problem. As long as I can reach out to many students, I will be more than happy. Gaurav, Omkar Gaurav, good morning. Then, who are the other students? Please introduce. 18. Arey wah, number is going up. 4 likes. Good. Meanwhile, when for next 5 minutes, I will tell you my arrangements. What I have set up a studio here in my home itself. Can you see? I will showcase you the. I don't want to disturb the camera setup, but nevertheless, I will show you through my laptop. There are. I have made one is a table lamp right in front. Then I have 2 screens, but the second screen I am keeping it idle. Like in my room, I use double screens, right? So I have one more screen here. I am not using it. Then I can show you this. Can you see this setup here, please? Can you see this? Yeah. This is a webcam, and that's the drawing sheet what you are observing on your screens. This I am going to switch over from my camera to this camera. And that's the arrangement that I have. And of course, I have made a set of pens. I have stationaries that have been maintained with. Then, of course, high-speed net connectivity. Thanks to Geo connectivity that I have, I can safely, reliably stream this video. Bandwidth is not an issue here. So that looks good. All set. Now it is, what's the time? 10:08. 17 students have joined us. I will wait feedback. Nice to see you, sir. Oh, hello. Who is this? Creepy freak. Creepy freak. I am not used to these kind of, because I am not much onto social platforms other than my own work. Creepy freak. This looks the interesting name. Santosh. Yeah. Good morning. Anyone? The others have not listed their name. Those who are on online, so please mention so that I can refer to your names. And also note, yes, I showed you my studio setup so far and how the things are happening. As I was saying, let me come back to still others are joining. So I think we can spend another 5 or 10 minutes on our discussion. two ways of live streaming, as I said. One is on YouTube, you can live stream your videos. No great challenge in that. Yeah, you will be seeing, or you can record one video, upload it onto YouTube. That can share the link, that can be seen. You want to go live? Yes, or either on your mobile or your laptops, you can go live and you can see the screen completely. You don't need to embed any. You don't need any streaming key. You don't need to embed any URLs or so. All you need to share is, once you go online, share that shareable link and send it across. But there the limitation is, you will not be able to see your showcase your PDF files. You will not be able to showcase your write, if you want to write down some equations, solve some solutions, or you want to showcase how you are, supposing if it's a CAD problem, you want to discuss it with your friends, how are you going to do this? But for that you need to have a screen capture device. Along with that, you should be, and this should happen parallelly. See, offline working is different, online streaming is absolutely different. So for this, and of course, you know the Zoom app issues. I have never used. I don't know what Zoom app is. So I always I checked out various apps. One more option, one more problem here you face here is, I'll tell you. You scan through any number of apps which can streamline stream these lectures. All of them are paid versions. There are no free versions available. They can record for 3 minutes and stream it, but beyond that you have to pay for it. I'm using what is called as OBS Studio 25.0.4. This is a free software, freely available. You can use this. It is slightly complex, but it has many versatilities, many versions. Like you can add your, you can showcase what you want. It is so flexible. You can go to YouTube, you can run YouTube. You want to go to Firefox, you can project that Firefox onto your screens here. That can be shown straight away without any lag, without any disturbance, as if you are seeing in front of your computer. You can show that. No, I want to write something and give the lectures. That can be done. Okay, just a minute. Look at this. Yeah, I want to write something now. I want to showcase as if I'm in a classroom. That can be done. Can you see this? Then no, I want to go back to my PDF file. Good. So I can refer to PDF file. Then I want to change. The same sheet is being seen, right? Let me change. Can you see this? Okay, we are discussing the problem on gauges. Let me go to gauge section here. Can you see this? Right? Can you see? All this flexibility is available. Yeah. All this flexibility is available. Now look at this, plain gauges. We are going to discuss about gauges now. Okay, let me just check how many are online so that I'll start my regular class. This is time is now 10:12. 16 students have joined us. That looks interesting. Then who is this? JM, good morning. Aniket Rao, good morning. Kiran Hiremat, oh, I see. So you are the epic footballer, is it? Great. Great to know about it. Next, I don't know who is this creepy freak. Creepy freak has not introduced the epic creepy name, please. Where is this creepy? What is his name? Who is this name? Epic footballer. I don't know. Did I miss out? Creepy? No. 16 students, 6 likes. Thank you. Okay. So that's about my arrangements and my way of doing the things. Hope we will have a good session. Can we start now? If someone can ping me, start sir, I'll go ahead. Or you want me to wait for some more minutes? Who is this? Wait for, yeah. Who is this? Somebody told, wait sir, we'll call, yeah, footballer, epic. Chetan Kumar Hubballi, good morning. Yesterday also you were present. Great to know. So you're back. Back to live streaming. Then epic footballer. Wait 2 minutes. We'll call our friends. Epic, who are you? I don't know the name. Anyway, did you call your friends or pass on your WhatsApp groups? Ask them to join me. I'll be more than happy. All my efforts, all the work that I did, I think it is paying. I don't know about the lecture. That is separate. But what I'm looking at, there are two aspects of looking into this. One is this live streaming, then capabilities, versatility, and another is content delivery. Definitely yes, I will put in my efforts to see that content also goes well. And then today I think it's going in a better way. So maybe tomorrow is a Sunday. Monday I'll take up the last unit. Maybe I can also discuss about unit number 3. I'll just revise. I have covered it in the class. Nevertheless, I will revise all the topics connected with unit number 3 on basic mechanical measurement systems, standardized measurement system that I can discuss. Then I can discuss about some of the definitions associated with measurements. Then I can also go ahead with a discussion on intermediate modifying devices. Then I will discuss about say primary, secondary, intermediate modifying devices, and then the final is readout devices, third part. Then I can as well go ahead with pressure gauge, then the various ways of that. Anyway, I will discuss that part during my next session. Okay, fine. Uh, 17 students have joined. I think good enough now. We will start. 16. One has dropped out. Good morning, Onkar Gaurav. Good morning. Yeah. Next. Let me just shift over. Let me recapture what was being discussed yesterday. For the benefit of the students who joined us today, I will quickly go through what was being discussed yesterday. Okay. And then we will continue with today's lecture. Please see that you can hold one pen and paper, and maybe your mobile calculator or whichever the calculator that you can use. Mobile calculator is fine. I am also holding pen and paper. Okay. I will, as and when things happen, I will showcase it here. Can you see? Everything is live, so I can write now. As of now, it is blank. So as the discussion goes on, I will write it here, and that can be projected. Fine. Design of go and no-go gauge for 25H7F8. That's my today's topic. Yesterday also I started with the same, right? Okay. For the benefit of students who are joining us today, I will recap what was being discussed, solve this problem once, half part of it once more, then continue in the today's time. But that will be quick, because those who have joined us today can refer back to my yesterday's video. I have shared that link. Maybe you must have seen that. If not, go through that. Okay. And continue with today's lecture. This time is now on 10:17. Please make sure that I would like to make sure that it should get over by 11 o'clock or so. And if time permits, meanwhile, you can, if you have got any viewpoints of yours, any comments regarding this presentation, you are most welcome to do that. I look forward to that. You can just chat. And please note, I'm not seeing the chat line. I'm on this separate software here now. OBS Studio software. I'll be looking into this part, but after 5 minutes I will switch over the window, go to your chats and observe those chats. Whatever you have sent, I will respond to that. Continuing with gauge design problem. Okay, 25H7F8. Let us break this problem into two parts. One is, it is limits, fits and tolerances problem, and another is gauge design problem. Okay, now with examination point of view, what are the things that is needed? Read the problem carefully. Problem may say that, I think I have uploaded some numericals with you. You can go through the question papers and previous question papers. Go on my Google homepage. You will see previous question papers. I'll tell you how the question paper or the pattern of question paper. Design limits and fit. Design a hole and a shaft. The tolerances for hole and shaft for say 25, 30, 35, 32, 33. That is the size, basic size. H, A, B, C, D, E, F, G, H, maybe H or maybe G hole, G5 or H7, in this case is H7, and shaft, small letter shaft, F8, F4, A, B, C, D, E, F, G, H. Okay, this is our XY line. Always I'll hold it this way. This is a scale. Right from A to H hole, they lie above XY line. This difference we call as fundamental deviation. Let me write it for you with a sketch pen so that it becomes easier. Can you see this please? Okay, done. I will quickly review the nomenclature. This looks okay. Done. Okay, let me change the laptop position. Right. This looks horizontal. Okay, now this is how we have to exercise. This is hole A, say this is D, this is H hole, this is say K hole, this is P hole, then this is Z hole. Can you see this? Z hole. Okay. This is called as fundamental deviation. This is called as fundamental deviation. And for A to H holes, fundamental deviation is positive. FD is positive. Next. Say something beyond H, J to Z. Fundamental deviation, and don't refer to J. KLMN, I can certainly say K to Z is negative deviation. This is fundamental deviation, FD. Okay. Exactly opposite is shaft case. I think now it's clear. Okay. Shaft nomenclature. See, this is A shaft, this is say D shaft, this is H shaft. Okay. This is negative fundamental deviation. FD is negative. And similarly, K shaft, small p shaft, small zf shaft, and this fundamental deviation here is positive. Clear? This is positive, this is negative, A to H, small. But I'll separately draw for H. Just have a look. H hole and H shaft. Their fundamental deviation is 0. Can you see this? They lie exactly on a basic line. This is our basic size. Basic size could be 50 mm phi, 45, whatever. What is given? Say 30, in present case 35 diameter. This is in mm. The present example is 25 mm. The present example, which means that this size is 25 mm. Okay, one sec, just let me look into the number of viewers here. How many have joined us, and is it going smooth? Let me just check on streaming channel and your comments. Good morning, Chetan Kumar Hubballi, Gaurav, that's all. It has come down to 8. Sorry, what happened? Who are online? Is it going smooth? Any issues? Concurrent viewers are 9 here now. Please give me the feedback. If there is no point in continuing, I can stop it as well. As I can see, the viewers were around 17 or 18. I don't know if they are getting the stream properly or not, and it has come down to now 8 or 9 and then 10. Okay. Kiran Parnoor. Okay, sir. Sanket Sabnavis. Good morning, sir. Yeah, good morning, Sanket. So should I continue? If it is the case, then I can go ahead. As I can see, there are 10 likes. That looks good. Impressive. Should I continue? Yes or no? Yeah, Chetan. Okay, great. Chetan Hebballi is here. He has given the feedback. Let me go ahead. Okay, fine. It will be interesting. Please don't worry. Just watch the Harshit Kulkarni. Okay, sir. Rutik Mensei. No issue, sir. Good. So these kind of feedbacks encourage me to continue further. Otherwise, every time in my back of my mind, it is always I'll be wondering whether streaming is happening properly and students are able to gauge, and then whether this is methodology is fine for you. every time this question crops up, because we will be concentrating more on our lectures, more on this. Lot many things are happening. 2 screens are happening, and then lecture, and then streaming. I don't know. Fine. Thank you. I'll continue. Good. So now coming back to the numerical 25 mm. As I said, H hole, H shaft. For H hole and H shaft, the fundamental deviation, that is the distance between this basic line and the minimum tolerance. So we need to understand the minimum and the maximum tolerances. If this is the hole, say this is 25 D hole, let's say D4, which means that this basic size is 25. This difference is fundamental difference. It corresponds to shaft D. You will have some equation minus, it is plus, this side is, can you see this plus? It is above XY line. So you will get, I'll show you the equations, fundamental deviation equations. Next, this corresponds to the IT grade. How much? In this case, it is 4. So IT 4. How much is IT 4? We have to find out. That will be given normally 6i, 8i, 10i. I don't know how much is this, but I have to just check. That is given to you people. You don't have to remember. Okay. This is the background of limits, fits, and tolerances. So come back. Okay. 25 H7 F8. So we the basic size is 25 mm. H hole with IT grade as 7, F shaft. The numerical will in the examination will be given with, this is the given data in the exam. I is equal to 0.45 cube root of D plus 0.001 D time, it is in microns. Mu is microns. Okay. Next, it is better that you remember, it's a fundamental equation that anybody can remember. Don't expect this to be, if in the examination not given, you may not have to say that, sir, the data is insufficient or the equation is not given. Don't say that. I is equal to 0.45 cube root of, can you see this? 0.45 cube root of D plus 0.001 D, okay, microns, wherein the diameter is given in terms of mm, and this D is called as nominal diameter. Nominal diameter is nothing but 18 to 30, that is a diametral step, standard diametral step. These are also given but not necessary. Examiner may give or may not give. You have to remember the basic diameter steps are 1 to 3, 3 to 6, 6 to 10, 6 to 10, 10 to 18, 18 to 30, 30 to 50, 50 to 80, 80 to 120, 120 to 150, 150 to, I don't know further. But if you remember, up to 120 more than sufficient. All or most of the applications are well within 100 mm. So you are expected to know this. Okay. Now, yesterday I solved the problem right up till hole design and the shaft design. A quick review: D value, root of D1 into D2, substitute D in terms of mm, 18 into 30. Next, I value, what you get here is in D value is in mm, I is equal to 0.45 cube root of D. I is equal to 0.45 cube root of D into 0.001 D, where D you substitute in terms of millimeters. So what you get here is in microns 1.307 microns, that is nothing but 0.001 mm. This was discussed yesterday. Now, step number 3, hole design. Simple, draw the sketch. H7, write it. This is the basic size. We need to find out two values of hole. This is the one size, this is second size. I have mentioned 1, I have mentioned 2. First size is 25 mm. Anyway, it is given to you. And fundamental deviation for H hole is 0. Okay. IT7. IT7, yes, it is given as 16i. Examiner has given you. You don't have to remember. Okay. IT7 is equal to 16i. 16i is nothing but, we have found out for I. IT 16 into 0.001 mm, you get 0.029029 mm. 0.0209 mm. Okay. Next. The two values of hole, just mention this 25. IT7 is equal to 16i, that is 0.021 mm. That means that second value is 25.021. So this is minimum size of the hole, this is maximum size of the hole, and both are positive values. Okay. Next, shaft design. Shaft design. Okay. First, draw the shaft. F shaft lies below XY line, right? I did discuss earlier. X, you can easily remember, keep this in your mind, XY line or basic size, A to H hole, then J to Z hole. These are on the below XY line. Next, A to H shaft, A to H shaft, XY line, these are negative fundamental deviation. Next, J to Z shafts, these are positive fundamental deviation. Keep this. Now, it shows F shaft. F shaft stands for with the fundamental deviation as minus. It is on the negative side. Don't worry, I mentioned fundamental deviation as 0.020 mm. It is just below the basic size. Okay. Now, we need to find out IT grade. IT grade for F8 is IT8. And what is fundamental deviation? How much? For F shaft, FD is given as minus 5.5 d to the power 0.41 minus 5.5 into 23.2 raised to 0.41, and the answer here you get is in microns. Please note, you need to substitute diameter in millimeters and the answer you get is in microns. Got it? Okay, 0.020. This is where the student tend to make a mistake. Commit. Either you bring it in millimeters or you substitute it in microns and mess up the units. Please don't do that. Substitute this in millimeters. This is in microns. Okay, tolerance for the shaft. Straight away, this is 25 minus fundamental deviation, that is value number 3, and this is 25 minus fundamental deviation minus IT8. IT8 I have mentioned, IT8 is equal to 25i, 25 into 0.001, that is 0.032 mm. Can you see? Okay, finally you get is 0.052. This plus this is 0.52, 0.02, 0.03, 0.5. So that means this is 24.948. How did you get this? 25 minus this minus this. Okay, that completes the first half of the portion which I discussed yesterday. Let us get going with gauge design today. I will discuss very simple step of designing the gauge. Okay, please give me some time. One sec. I'm trying to locate one drawing sheet. I think I misplaced it somewhere. Just a minute. Let me see how many have joined us. 14. Who is this? Santosh. Continue. Wait. Just a minute, Santosh. Guruling KST. Yeah, who is this? Hello, Guruling. I think the things are going on. 14 views. Just give me some time. Just hold on for a moment. I'm trying to locate one sheet. Okay. No, I think I'll have to solve it again. Never mind. Just a minute. I will showcase this entire thing once more. Probably I will have to do the drawing sheet. Okay. Let us get going with the solution of the gauge design. Okay. Can you see this, all of you? Okay, give me some time please. I'm trying to show you the way how gauge is to be designed. Okay, gauge design consists of two parts, go and no go gauge. Let me also keep this as a reference. One is go gauge, another is no go gauge. Let me increase the zoom size. One sec. Can you see this? One second. Just hold on. Sure. Okay. I think this is visible now, right? Is it visible? This drawing sheet, is it visible now? Just please check. Okay. Let me just check. Okay. Can you see this? I think it's okay. You're able to view this. Okay, good. Next. So we'll have two parts. One is gauge design for hole. Another is gauge design for shaft. Okay, so now gauge design for 25H7, H7, that is hole. For hole we need a ring gauge, plug gauge. See, I want to check, if you want to check this hole, I have to fix a plug gauge, and one is a go plug gauge, another is no go plug gauge. Okay, so there are two dimensions that I need to find. One more important concept here for designing the gauge is that wear tolerance. You know, by repeated use of the gauges tend to enlarge this because of the wear and tear. The gauges tend to enlarge in case of ring gauge. So we need to give the tolerance. Normally for gauge tolerance, the gauge tolerance is taken as 10% of the hole tolerance or the shaft tolerance. That is 10% of this size. 10% of this is taken as tolerance on this side and tolerance on this side. And for shaft, 10% of 0.032 mm. Can you hear? Did you understand? Gauge tolerance, you know, supposing if this is the gauge. Okay, let me, I think I have some mechanism here. Sure. Yeah. Supposing this is the gauge. Okay. Because of repeated use of this gauge, this tends to wear out. So this wear allowance is given as 10%. Supposing this is being checked as a go gauge for certain hole, this is a ring gauge. I want to just check a shaft, whether it is passing through or not, right? So this is given as 10% of the tolerance for hole, and similarly for shaft it is 10% of the shaft tolerance. Okay, now with this respect to this, 0.021 mm is tolerance on the hole side. So what should be the ring gauge tolerance? It should be 0.0021 mm. Okay, with that as background, and let me just check my PDF file. One sec, please hold on. Just hold on. 25H7 F8. Okay. I got directly the values. I will show them here. Okay, 25H7 hole. Now, here I want you to put more concentration. I'll put a very simple way of solving. Don't worry about positive side, negative side, fundamental deviation, whether to be added, whether to be deleted, nothing. Just follow my steps as far as hole design and as far as gauge design for hole and shaft is concerned. Okay, I'll try to draw with sketch pens. So now, straight away, is it visible? This is visible, right? Okay. Now, this is hole, H7 hole. H7 hole. We have already found out its value as 0.02. How much is that? 1 mm. Okay, and this is 25. This is 25.021. Obviously, 25.021. Okay. Now we need to design the gauge for this. Okay, two parts. One is go gauge, another is no go gauge. I will draw it with another pen for simplicity. I will mark it here. I will mark it on this side. Is it visible? Others can please let me know your view. Santosh, is it visible? Drawing sheet, is it visible? Drawing sheets. Otherwise, I'll have to zoom in. I'm waiting for your response. Is it okay, or should I reduce the zoom size? Should I change the zoom size? Let me just check what is your feedback. Visible, sir. Okay, good. Thanks, Ashish. Thanks, Epic. Okay. Next, where is this? Right. Okay. So now I will draw it with another pen and a pencil. Keeping, if you follow this step easily, I am pretty sure those of you who attended this lecture will be able to solve any problem associated with limits, fits and tolerance. That much guarantee I can give you. Okay, next, same thing, I am continuing here. Okay, next, I am just drawing these limits of hole. This was our hole, this is the hole. Okay, now all you need to do is, for go and no go gauge, just draw two rectangles here next to this. I just follow this step. Two rectangles. Okay, one, then another same size rectangle here. Same size rectangle. Can you see this? Okay, I'll show you once again. Don't worry. Both should be of the same size. Okay. This size is, okay, I think this pen is not visible. This is 0.021, right? 0.021. How much should be this? This is 0.021. Obviously this is 0.0021 and same 0.0021 here, 0021 mm. All the values please keep them in mm. So far clear? Okay. Now all you need to do is write one as go gauge. This is go, this is no go. That's all. Got it? One is go, another is no go. Step 5, next step, that is plug gauge design. Plug gauge design for hole. All you need to do is draw two parallel lines. One sec. Okay, sorry. Yeah. I'll write here gauge tolerance is equal to 10% of gauge, this is gauge tolerance is 10% of hole tolerance value, or shaft tolerance value, either ways is okay. Shaft tolerance value, in this case it is 0.0021, so this is 0.0021. okay, next part, what we have to find out here? 4 values, 1 2 3 4. I'll mark the 4 values here, you try to follow them mechanically. There is no mathematics, there is no computation, no integration, no differentiation. Straight away it is 4 values that you have to find out of which 2 are already known to us. Okay, what are those 4 values? 1, 2, 3, and the last one is top portion 4. Got it? 2 values of go, lower limit of the go, higher limit of the go. 2 values of no go, lower limit of the go, upper limit of the no go, out of which 2 are known to us. What are the 2 values known to us? Look at this. 1 is known to us, 3 is known to us. Yes or no? 1 is known to us, 3 is known to us. What is that? 1 is nothing but lower value of the hole, 3 is nothing but upper value of the hole. So 2 are known. Another 2 we have to find out. How should we find out? Simple. Look at this. This is 25. I have written here. Okay. Go gauge. One value is 25.000. Second value is 25 plus 0.0021, right? 0.0021. Is it difficult? 0.0021 mm. That is nothing but 25.0021 mm. So this is go value, go limits. That's all. One part is over already. Look, go limits. One size is 25, another is 25.0021. How did you get 25.0021? This one, 25.0021. How did you get 0.0021? That is nothing but 10% of 0.021. And this 0.021 is nothing but IT value, IT7, IT8, IT10, right up till IT16. IT7 represents something like, you should be able to tell me now whether it is a smooth finish, rough finish, what kind of operation it must have been done with. Probably this is something done with either milling or lathe. If you go H8, somebody asking if it is H9, what kind of operation? It could be drilling operation. And if it is mentioned H15, H12, H14, H15, it should be some pressing, blanking. H16 would represent casting. That will have 1000 I. So that means high tolerance. That means this size will be bigger here. Of course, it is in micron level. Even if it is more or less, it will always vary in terms of micron level. Okay, coming back to 1, 2. Did you understand? 25.000, 25.0021. I think now the time is, how much is this? Time is 10:49. Okay, I have another 50. Yeah, another 10-15 minutes. I should be able to wind up this part. Okay, now I want to find out 3 and 4, out of which 3 is known to us. Only 4th is to be found out. Okay, go gauge, no go gauge. Sorry, let me use the other color. Go gauge, no go gauge. No go gauge, one value is this. This one, 3rd. Can you see this? 3rd. This size. So how much is that? 23.021. 23.021. Yes or no? 23.021. Okay. What is the other value? Simple. This is value number 3, value number 4. 4 is, sorry, not 23. How much is this? 25. 25.021. Next, 25.021 plus 0.0021. This part. 0.0021. Got it? I think you will get something like this value. How much is that? Let me just check how much is the value I'm going to get. Can anybody tell me? Let me just check. Please give me time. How much is the value here? Yeah, 25.00 25.021 plus 0.0021 25.023. This value is nothing but 25.023. That's all. So 4 values, one is known, 2 is found out, 3 is known, 4th is found out. 1, 2, 3, 4 values. Okay, please let me come back to this transition here. One second, just hold on. Video capture, okay, it's happening. Please give me some time. I'm trying to work out on something here. I think this is freezed. What happened here? Please hold on. Yeah, I got it. Sorry, there was some interruption here. Okay, good. So now, can you see these values? I have mentioned here 0.02, same thing. Go here, no go, and 0.00209, and it's 0.003. You can mention this one. So this is nothing but your gauge tolerance. Now, let me move this. All the 4 values are mentioned. I have reached up till 4th or 5th decimal, but you can reach only 4 decimals. No go gauge I have mentioned here. Let us come back to this. One sec, just hold on. What happened to our drawing sheet? Okay, right. So I'll just quick recap all the 4 values. This is the hole. H is 7. Just for your reference, I'll show this. H is 7. Draw another 2 lines. Make these 2 parallel lines. Okay, I just made it larger size. Write this as go. This is go. This is no go. Okay, now this is 10%, this is 10%, 10% of this value, and this value is 0.021 mm. So that means this is 0.0021 mm. This is also 0.0021 mm. So now 1, this is 25 of course, 25. So this is, first one is 25.00, second one is 25.0021, next third one is already known 25.021, 25.021, and this is the fourth value 25 point, how much is that? 25.023, 023. That's all are in mm. 023, 25.023. Please calculate this at home. After that you should be able to get the answers, not a problem. Now if this is over, half the portion is over. Next comes, for the shaft we need to design plug gauge. If this is the shaft, we need to design a plug gauge, right? For shaft, ring gauge. Let me say this is the ring. This is the ring. One is go ring gauge, another is no go ring gauge. Procedure remain the same, direction will change. Let me go back. Let me see how many are online now. 12 students are online. Who is this? Pratik, visible sir. Okay, good. So 14 likes, that looks good. I expected more students, but nevertheless, shaft design now. Okay, shaft design is over. For the shaft, we need to design the go and no go ring gauge, go gauge and no go gauge. Procedure will remain the same. I will show you on drawing sheet. Okay. Can you see this? Okay. This is F8. What is that? F8. Already we have found out these sizes. These sizes are found out to be, how much of those? Can you see here? I'll just only write these these sizes. This is 24.98. This size is, can you see? Okay. 24.98. It's already found out. And this is also found out, right? This size 24.948. 24.948. This value is less, this value is more, because this is towards, this is minus side, this is the lower deviation of the shaft, this is lower deviation of the shaft, this is upper deviation of the shaft. Okay, this is maximum metal condition, this is minimum metal condition. If a shaft is given something smaller than this, say 24.8, 24.9, then the shaft gets rejected. If you are given a shaft which is more than 24.998, you can still work on that, you can get the price reduced, or you can send it back to the manufacturer, he can rework that and he can sell it to you, come back. But if the value is given, if the shaft given is less than 24.94, straight away it goes for rejection. Entire work is lost, or the material is lost, wastage. Next, we need to design the plug gauge. Simple, step number 5 and 6, 4 values. I'll show you here, follow that mechanically, straight away, mechanical. Okay, I'll show you with another drawing, another pen. All you need to do is just to draw 2 lines below this. Okay, earlier we were drawing it for hole, it was above this, right? Here, can you see? For hole, it was above line, here also above basic line, but for hole, it is below the line. That's all is the only difference. But the distance will remain the same. How much was this? This was for shaft, can you see? 0.032. Can you see it? Okay. So this is 0.032. So that means this will be 0.0032 mm. Always don't forget, it is in mm. 10% of this value. 10%. This is called as gauge tolerance. Gauge tolerance. Okay. This is gauge tolerance. Exactly same gauge tolerance you have to give on this side. Okay. Now, in this case, the change here is the top part becomes go gauge, the bottom part becomes no go gauge. This is go gauge for shaft. This is no go gauge for shaft. Is that clear? This is go, this is no go. Difference between hole and shaft, what we did, this is a ring gauge, for that it's a plug gauge, and in case of hole, the tolerance was taken above basic size, and above this size. This is no go, this is go. Here, this case, just below XY line, this is no go gauge, this is no go gauge. Okay, now what are the values that we need to find out? Another 4 values. Okay. Can you say this? 5, 6, 7 and 8. If you find out 8 values, 2 values for go gauge, 2 values for no go gauge, problem gets 100% over. Now, out of these 4, already 2 are known to us. What are the known values? Have a look. This is known, 5 is known. 5 is known already. 5 is this value. This we have already found out. 5. Next. 7 is also known. 7 is also known. That is 24.948. Here it is. Here it is. So 5 is known. 7 is known. You have to find out only 6 and 8. Value number 6, this is go gauge. Go gauge for shaft. Go gauge for shaft, 5 and 6. 5 is 24.98, 6 is 24.98 minus this value, minus 0.0032. 0.0032. That's all. How much is that? 24.98. One sec. $24.98 minus 0.0032. 24.97. 24.9768. So 977 mm. Okay. Next, no go gauge. No go gauge for shaft is nothing but 7 and 8. 7 is known already. 7 is 24.948 mm. Next, 8th value is 24.948 minus point this value. Can you see this? So 24, this value, this is go gauge, this is no go gauge. 24 point so and so minus this value, 0.0032. How much is that? 24.948 minus 0.0032, that is 24.945. 24.945 mm. That's all. Done. 8 values. 8 values of go and no go gauges for plug and shaft. I will recollect everything right from the beginning. Okay. 15 students now. Some 2 new students have joined me. I welcome them. Totally 15 likes, 14 students, 15 students. It's going good, pretty good. I'm happy about this. Let us quickly review all our problems done so far with special emphasis on gauge design. I will repeat the steps. This part I will not repeat, it has been repeated enough times. One is first is fundamental, this is basic diameter, what is this? Nominal diameter find out. Then this is tolerance. Next, hole design. One is basic size, another is H7, IT7, find out this. So you get 2 values of hole, 1 and 2. Next, 2 values of shaft, 3 and 4. Value number 3, value number 4. This is third, this is fourth. This is third, this is fourth. How did you get? This is fundamental deviation. This is already given. This equation is given, fundamental deviation is given by the examiner. So you can find out, and only thing here is answer you get here is in microns, convert that into millimeters. So, and please see that you write the values in the drawing, it becomes much simpler. Once you have written all these things, you don't need require the numerical. All you need is your straight away the next hole design and the shaft design. Hole and the shaft design could be done by using drawing sheet. Okay, quick way of drawing. Entire thing I will draw in one sheet. Okay, both for hole and the shaft. Follow me in this aspect carefully. In one single drawing, I will write down everything. I think it should be easier. Okay, hole, simple, extend the line, make 2 lines here, make 2 lines here. Okay, this is no go, this is go. That is, for holes you use plug gauges. These are for hole, use plug gauge. Here we need to find out 2 values of go gauge, 2 values of no go gauge. Okay, I'll write down in another color. Go value, no go value. So go value, I think this is not working. Yeah, go value number 1 and number 2. This is 1. Next, no go plug gauge, no go plug gauge number 3. Can you see? Okay, number 3, then number 4. So 1, 2, 3 and 4. Out of which, please note, we know 1, we know 3. Already we know this. This part is known, this part is known. So these two, 1 and 3 are known. We need to find out 2 and 4. That can be found out. Once you know this, you can find out this. This is 10% size, 10%. Okay, we can find out all the remaining. So 1, 2, 3, 4, 2 values of go, 2 values of no go. For hole is over. Now for shaft, we use ring gauge. Ring gauge. Let me draw the shaft for you. Simple sketch. Okay, it is an F shaft, right? F, what was the cat? F, what is it? F8. 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 Done. All you need to do is extend this on the opposite side. Here it was above the line. Here we will be drawing it below the XY line. Okay. Now for ring gauge, again go ring gauge, no go ring gauge. For go ring gauge, this is go. One sec. This is no go. This is go. This is no go. Okay. How many values you have to find out? 2 values here, 2 values here. So let me mark them. 4, 1, 2, 3, 4 are over. 5, 6, 7, and last one 8. Clear? 5, 6, 7 and 8. 2 values of go, 2 values of no go. No go. This is go, this is no go. Okay. I had drawn actually in this way, but in this mess up, I don't know where I lost that card. I wanted to showcase that card for you people. I lost that. nevertheless this is fine. You please solve it by yourselves. It is also uploaded. Can you see here the values? I'll show you. Wait. Wait. Just a minute. Yeah, can you see this? Can you see these values? Basic size and then wear lines, okay, and then minus 00. All those values you can find out here, and you can start solving the problem. There is some, I think there is a mistake here. I will fix that later. If there is a mistake, I'll just rectify that. I think I am right. We'll follow this. Okay, so 8 values. Finally, come back to this main sheet. Design, go and no-go gauge. Design, go and no-go gauge, 25X7F8. First half, design of hole and design of shaft. Second half, design of plug hole. For hole you need to have plug gauge. For shaft you need to have ring gauge. So design of plug gauge and design of ring gauge. And in the design of plug gauge you have go and no go gauge, and in the ring gauge again for the shaft you need to have a ring gauge, go ring gauge and no go ring gauge. Okay, so in this case there are no go and this is go. So 2 values of go, 2 values of no go. Next 2 values of go, 2 values of no go for shaft. That should complete my lecture today. This is 11:12. I think I have taken 1 hour 12 minutes. 14 students here today. Finally, on an average I can say 14 students. It has been a very interesting experience for me. Hope you have enjoyed my lecture. Let me know your feedback. As I can see here, all are able to hear my voice today. Yesterday there was some issue, I remember. Audio was not very clear or some streaming issues. I think all those have been fixed today. Okay. Depending on your feedback, I'll take up next time my another lecture. Live streaming will be planned on Monday, 10 o'clock. Please note these timings. Monday 10 o'clock. I will share the link just before. What happens is this link will be, we'll get this link just before we go live. So I will copy that link and I will share it with Professor Vinay Kulkarni. And thanks to Professor VK for communicating with you people on a regular basis. Even Professor Harshit. Harshit is also equally involved in this part, I believe. I think he has joined our discussions. Probably he is getting this link through your student groups. Nevertheless, I thank Professor Harshit. I thank Professor Vinay Kulkarni for especially the VK. I have been troubling VK, Professor VK on repeated basis, I must say. Every now and then I keep sending him a message, VK, please circulate this among the student group. He immediately does. Without even a minute's delay, he is doing it. Thanks VK for that purpose, for that favor that you have been doing. Sorry for the trouble that I have caused you in this regard. Nevertheless, today I am very happy that 14 students came online and they were able to attend my lecture and look at the 2 views. I have tried my level best to showcase, and we can always discuss on this. You can give me the feedback about how to go ahead this solution. But another important, equally important aspect is I am able to get connected to you on a one-to-one basis. That makes me feel happy. So next, and please remember, we don't have books here. Without book, I have tried whatever in my mind, and through my PDF file I have uploaded. So that I am showcasing. You can go through this PDF file. One sec. Let me just showcase what is contained in this. Go through this PDF file. Look at various. I have only covered the numerical. Theory part you can always discuss. You can understand easily. Go through the Taylor's principle of go and no-go gauge design. It is a very important topic from your examination point of view. In the examinations, normally you have seen the question paper saying sketch and explain Taylor's principle of go limit, Taylor's principle of no-go limit. Then in the Taylor's principle, the go gauge should be full form. You should mention these 2 points. The designation is applied to the limit of 2 limits of the size, which corresponds to the maximum material limit condition, that is upper limit of the shaft and the lower limit of the hole. Okay, Taylor's, please try to understand. If you wish me to take up this Taylor's principle, You can just mention there in your chat box. I will take it up nevertheless. And these are a simple theory material. Taylor's principles, I said this. Yeah, this is the plug gauge. Can you see this? This is the plug gauge. Yeah, this is the plug gauge which is used to check the hole. This is a two double-ended. One is plug and one is go and another is no-go gauge in the same single shaft. This is, I can say, 12.6 mm, 12.9 mm. So go could be 12.6 and 12.9 is no-go. See here, if you observe carefully, it is mentioned go and no-go. That means the tolerance here is 0.3 mm given. And this is go thread gauge. This is no-go thread gauge. Okay. Next. Similarly, and if you see this go plug in a single shaft on single side, they have mentioned mean one single shot you can make out whether it is a go or a no go gauge, whether the component can be accepted or not. One second, just hold on. I think there is some issue. Yeah, sorry, I was not knowing here. Yeah, I think now it is streaming. Right. Just come on. I think I missed out on this. Yeah. This is go thread gauge. This is no go thread gauge. This side is a go part. Can you see 12.6 mm? This is 12.9 mm. So this is no go part. It is mentioned here. If you can observe 12.9 and go gauge. Here can you see 12 go gauge and no go gauge. It is mentioned here. Next, go and no go gauge. Next, ring gauge. Yeah, these ring gauges are used for, and you have a separate ring gauge for go. In case of plug gauges, both of the go and no go can be made in single shaft. But in case of ring gauge, for both go and no go, you need to have separate gauges. One is go ring gauge, another is no go ring gauge. Okay, and fine. Go through my PDF material, all these equations and materials. Now the number of students have reduced 10. I think we will stop at this point. We will continue on Monday. Let me know your feedback, and last final word, please take care of yourselves, stay fit, then send the feedback. I'll be looking forward to your feedbacks. You can just circulate this video. Once if it gets completed, it gets stored in a YouTube. You can circulate this. I will also circulate that link. Thank you all for being online and giving your time, and also the feedback that you are receiving, and some messages that you sent. I've seen all those. Then it has been a very, very good experience. Have a stay blessed. Okay, good day, bye, thank you, have a nice weekend.